All right, buckle up, listeners, because today we're diving into the world of computer networking. We're going to be unpacking the OSI model, a concept that I think it's fair to say sounds a lot scarier than it actually is.
Yeah.
You sent over some excerpts from this one Modelo OSI TCP BTIP.pdf document. And yeah, you're right to call it dense, but don't worry, that's what we're here for. We're going to take this model apart piece by piece, and by the end of this deep dive, it's going to make a lot more sense.
Sounds good.
Think of this like we're tracing the journey of a single message as it travels across the internet. We're going to stop at all the checkpoints along the way, figure out all the protocols, and we'll see just how the OSI model provides the framework for all of this to happen. So let's kick things off. Imagine you're sending a simple text message, just like a funny meme or something, to a friend on the other side of the country. Seems easy enough, right?
Right.
But behind the scenes, there's a ton of tech working to make sure those bits of data actually get to where they need to go.
Yeah, and it's way more complicated than you might think. It really is incredible just how much coordination has to happen for something like that to work. And that's exactly where this OSI model comes into play, because it provides a structured, layered approach to communication over a network. It makes sure that all these different systems, no matter how different they are, can talk to each other and share information.
Okay, so structured and layered. I get that, sort of. But like before we had this OSI model, what was going on? Was it just total chaos when computers tried to connect to each other?
Pretty much, yeah. Back in the early days, you had all these different companies coming up with their own proprietary protocols, their own languages, so to speak. So trying to get two systems to talk to each other back then, it was like trying to have a conversation where no one spoke the same language.
Oh, I get it. So like trying to order a coffee in a foreign country when I don't speak a single word of the language.
Exactly.
Definitely not a smooth process. So the OSI model swoops in to be the universal translator for all this network jargon.
Precisely. It lays in the ground rules, establishes a common language, and that lets any two devices on the network talk to each other. It doesn't matter what hardware or software is running underneath, they'll be able to communicate.
Okay, now it's starting to click why this is such a big deal. But we keep saying layers, and I'm not totally sure what that means. Can you break it down for me? What do these layers actually do?
Absolutely. The best way to think about it is, imagine the OSI model is like a 7-layer cake. And each layer has its own job to do, its own purpose. And just like when you're building a cake, you do it one layer at a time, right? Well, data transmission works the same way. It goes through each of these layers, one by one. And at each step, each layer adds its own crucial component to the process.
Okay, so it's a 7-layer cake of internet communication. I like where this is going.
Yeah.
So what's the first layer we'd run into on this little journey our text message is taking?
So the first layer, the very foundation of our cake, is the physical layer. And this one's all about the actual physical transmission of the data. So we're talking the cables, the connectors, the electrical signals, all of that. Remember that bits on the wire idea from the document?
Yeah.
That's the essence of the physical layer.
Right. So it's about the actual physical stuff, the pipes and wires that the data travels through. So it's less about the message itself and more about making sure there's an actual path for it to travel.
Exactly. Think of it like you wouldn't try to send a letter without putting it in an envelope first, right?
Right.
The physical layer is basically the envelope, making sure those bits of data have a way to actually travel from point A to point B.
Got it. So our meme is all packed up in its little digital envelope. What's the next stop on its journey through the internet?
So from the physical layer, we move up to the data link layer. And this is where things get, well, a little more technical. The main thing to remember about the data link layer is that it's all about making sure the transmission goes smoothly across that physical link we were just talking about.
Okay, so reliable transmission. Does that mean it's like the proofreader making sure there aren't any typos in our meme before it goes out?
Exactly. It's like, you know how sometimes your phone will autocorrect what you're typing into something totally ridiculous?
Oh, yeah, all the time.
Well, the data link layer is like that friend who's really good at grammar, the one who swoops in to fix those errors before you hit send. It makes sure all the data is in the right order and that there aren't any mistakes.
Okay, I'm with you so far. So our meme's all proofread and ready to go, but how does it actually make its way across the internet to get to my friend? Does it just like bounce around randomly until it finds the right phone number?
Not quite. That's where the network layer comes in. Remember we were talking about logical addressing and routing? This is where that comes in. It's the network layer's job to look at the data and figure out the absolute best path for it to travel. Kind of like how your GPS figures out the best route to get you through traffic.
Oh, okay. So it's like our little data packet is hailing a ride-sharing service, and the network layer is the algorithm finding the best route and making sure we don't run into any digital traffic jams along the way.
Exactly. Every device on the internet has its own unique IP address, which is basically like its home address. And the network layer uses those addresses to figure out where the data came from and where it needs to go.
And it's smart enough to change things up if there's like a roadblock somewhere in the network.
Exactly. It's constantly recalculating, finding the most efficient path, even if there's congestion or a server crashes.
Wow. Okay, that's pretty cool. So we've had our meme proofread, packaged up, and now it's cruising along the information superhighway, no problem.
Right.
What happens next?
Okay, so now we're at the transport layer. This one's a big one because it's how we make sure our meme gets to its destination in one piece. And by that, I mean not as a jumbled mess of pixels. It's responsible for what we call end-to-end delivery and flow control.
End-to-end delivery. So it's not just about knowing the right address, but making sure the whole message actually gets delivered.
Exactly. Think of it this way. Let's say you're mailing a huge jigsaw puzzle.
Okay.
You wouldn't try to stuff the whole thing in one giant box, would you?
Probably not.
Right. You'd break it down into smaller pieces, pack them up separately, and then send them off. That's basically what the transport layer does with what we call segmentation. It breaks down big chunks of data into smaller, more manageable packets. That makes them a lot easier to transmit.
Makes sense. So now our meme is like a bunch of puzzle pieces flying around the internet. How do they all get put back together on the other side?
That's where reassembly comes in. The receiving device also has a transport layer, and its job is to take all those little packets and put them back together in the right order, like a digital jigsaw puzzle. That way the meme is whole and ready to be enjoyed.
So my simple text message really has been on a wild ride. We're already through 4 layers of this internet cake, and I have a feeling there's more to come.
You're right about that. We've still got a few layers to go. Now we're getting to what we call the upper layers of the OSI model: session, presentation, and application. You can think of these as the finishing touches, making sure everything looks good and runs smoothly for the user.
Okay, so if the first 4 layers are like the behind-the-scenes stuff, making sure the data gets where it needs to go, these top layers are like the actual bakery, where they put the frosting on the cake and make it look all pretty.
That's a great way to put it. So first up, the session layer. Its job is to manage the connection between the two devices. It makes sure the communication stays open and synchronized.
So kind of like the phone call itself, making sure the line stays clear. So kind of like the phone call itself, making sure the line stays clear.
Exactly. And then we've got the presentation layer. This one's all about making sure the data is formatted in a way that both devices can understand. Like, think about all the different file formats out there, or encryption that's all handled by the presentation layer.
Got it. So it's making sure my friend's phone can actually open and display this hilarious meme I'm sending. Which brings us to the grand finale, the application layer. That's where I actually get to see the meme on my phone, right?
You got it. The application layer is what you interact with directly. It's all the apps on your phone, the programs on your computer, all the software that lets you do things like send emails, browse the web, or even share memes.
This is way more complicated than I thought it was. It's really amazing how the OSI model breaks it all down into these manageable pieces. But I know you mentioned there are some people who aren't totally sold on this model. So what are the downsides? If it's this perfect framework, why isn't it the only game in town?
Well, you have to remember that the OSI model, like any model, is really just a simplified way to look at things. And in the real world, things don't always fit so neatly into these boxes. One of the biggest criticisms you'll hear is that it's really complex. There are a lot of different layers, and sometimes the lines between them can get a little blurry.
So maybe a little too organized. Like having our meme go through too many security checkpoints could actually slow things down.
That's one way to look at it. And that complexity is one of the reasons why another model, TCP/IP, became so popular. Remember that monolithic block versus layered approach we talked about earlier?
Yeah.
TCP/IP is definitely more on the monolithic side of things. It takes a more streamlined approach, combining some of the functions of the OSI model and condensing it down to just 4 layers.
So TCP/IP is like the express lane, and OSI is more like taking the scenic route.
I like that analogy. TCP/IP is all about practicality and efficiency, and that's a big part of why it became the dominant model, especially in those early days of the internet.
Okay, so TCP/IP won the popularity contest. But that doesn't mean the OSI model is useless now, right?
Not at all. It's still a really valuable tool, especially when you're first learning about networking. Even if you're never going to work directly with OSI protocols, understanding how this model works is really helpful. It gives you this framework to understand how networks function at a fundamental level.
So even if it's not always a perfect representation of what's happening in the real world, the OSI model is still the blueprint.
Exactly. It gives us a common language to talk about these concepts, even if the underlying tech is constantly changing.
This has been a wild ride. We started with a simple text message, and now I feel like I've learned so much about how the entire internet is structured. It's incredible to think that all this is happening behind the scenes every time we send an email, watch a video, or yeah, share a meme with a friend. So for our listeners out there, the big takeaway here is that layering is powerful. It's about taking a complex system and breaking it down into smaller, more manageable pieces. And that's an idea that applies to so many things, not just networking. But hey, that's something to think about, right? Until next time, keep exploring and we'll catch you on our next deep dive.